Hello. Welcome to my talk about large-scale application configuration management. I'm working currently at bwin as an engineering manager. I'm there already for 11 years. I worked on different topics, projects from casino integrations to web frameworks to redirect engines and now configuration management and trading. So in the talk, I will give you a brief overview of what bwin is doing, then information about the system that we have built to address the application configuration needs of our company, then our learnings and some stability concepts that we apply. So bwin is since about a year part of CBC Holdings, online gaming and entertainment group. We have 12 online gaming brands. We have 15 offices with around 2,800 employees. We have a lot of products here. You can see our most important ones, sports, poker and casino. As I said, currently I'm working in the sports department. It's an environment where we have a high frequency of updates to process, transactions to run. During sports events, there's a lot of data coming in that we have to process, that we are getting scores in, we are getting information about betting behavior in, we have to do risk management based on that, so it's a high frequency environment. You can see here we are offering 90 different sports, about 30,000 betting options per day, quite a lot of bet placements per year. So although the Vienna Development Center is mainly focused on sports betting. What's important to know is that we are basically a development company, so all of this main software that we are using is self-built. We are running a real money business. People are betting, they want their money quickly, of course, when they want. We have omni-channel setup, so people can use our apps, they can use our webs. So quite a big offer. And of course, we want to model that in an efficient way. So that's also why we came then to this configuration management. We have great teams. We have 90 different Scrum teams across 7 locations. In the Vienna Development Center, we have about 400 people, developers, testers, business analysts, application engineers working and running on the applications. Here you can see some of our characteristics, I would say, business performance numbers. We have about 1.3 million unique customers per day. We are very much driven by peaks when there are sport events. Then a lot of customers are storming the site. So in sports, we can have up to 800,000 people at the same time, concurrent customers trying to look at games. They are starting, they want to place their bets, they want to see how the game develops and then adapting also their bets. Up to 250 bets per second, a lot of API requests. We have 20 data centers where we are running our own hardware and applications. So, and in this big setup, we have, of course, a lot of dedicated back offices for applications. So the talk I will do today about the configuration management is mainly about the general purpose key value store, basically. What challenges do we have for this topic? We have about 900 different consumers, virtual machines, running applications that are maintained and developed by 26 different teams around our locations. Mainly on the web applications, on backend services. Before the project that I am talking about here, we had configuration spread partly in different locations. So we had .NET configuration files, web config, app config, we had a custom built JSON config store, we had partly people fleeing to the content management system that wanted to have more frequent updates, some databases with config but without back offices. And a lot of these changes for the applications required restarts or rollouts. So this was quite a tricky setup for the applications that didn't have their dedicated back offices, and we knew we can do much better. Looked at other approaches from systems like Spring Cloud Config or Archaeus from the Netflix open source stack. that have similar things in mind. You have an application and you want to update the configuration at runtime and very quickly. There's now even a .NET connector for Spring Cloud config, steel toe. You can use Zookeeper, so there are a lot of different options, and we try to learn from that and also finding out our requirements. We came basically to one very high-level requirement and a lot of details. We wanted to be able to update configuration on all the consuming clients of this system at runtime. Within seconds from a central back office that can only be used by any non-technical user. So business analysts that want to model the behavior of their features due to some marketing needs, due to some regulation needs. As I said, we are operating in different brands for different countries, different regulations, and we have to make sure we can adjust the offer as required in these setups. Then, of course, we thought about how to do all of this, and now I will present you our solution, basically. Here you see an easy architecture overview. So you can see the happy customer, developer, tester, whatever, working with a configuration back office where they want to be able to find their features and tune them to their needs. A feature could be feature flag, like we heard before, but it can also be something, I want to have this amount of items per page, I want to have this kind of tracking configuration, I want to have, yeah, we even put our database connection strings in, I want to have this and that cache timeout, I want to have a lot of different things. So this is then also going to a central storage. Where we expose the information via two different APIs depending on the needs of the customers. And as you see, we have two big groups, web applications that we are traditionally running in a multi-instance setup, which means for bwin, we have instances running here. For Party Poker, we have instances running on other machines, and they are also handled by different teams. So these teams are quite independent. They can work on their own. They have their own business analysts. They are fed from core technology teams with a framework that is supporting them for all the core work, basically. Access to content management system, manipulation of tracking, access to shared cache, and all of these things. And that is also where we then hooked in with a configuration provider, of course. So these applications are running multi-instance. Of course, within this context, also in instances, because all of them have to be highly available. There cannot be any downtime on these webs. All rollouts, all updates have to be without the customer noticing it. And then we had a group of backend services that are running multi-tenant. So they have a bit of a different characteristics, and they also had something in place already, so they wanted to use a push API versus the web applications where we implemented a pull concept. They are polling basically for the updates. So this is the high-level overview. Of course, we thought about the domain model. Actually, we wanted some kind of key values store on steroids. So the important thing for us that we can have keys that can have multiple values depending on a context, business context, technical contexts, whatever. I will explain that on the next slide. These keys are then structured into features and containers that allow it to version them explicitly and to address permissions and other things based on it. The consumers then request the configuration based on these containers from the different APIs, depending on their needs via the pull or push concept. So what does this variation mean? Of course, it should be possible to set different key values depending on a context. The context could be something simple like the environment. You want an item enabled on dev, you want it disabled on prod. But you might want it enabled also on prod for German customers on Party Poker, for example. So it might get very specific. So you might have a lot of different variation factors playing together. And some of them are basically only assigned to the application. I mean, this depends a bit on how you implement it, multi-instance, multi-tenant, like environment. The application is waking up and it will always be in prod. We have no multi-environment applications. But other things are changing with every request. So if you want to vary something by device or country of the user or language, it's different, and you have to resolve the values at runtime all the time, of course. So we made a differentiation in that also. In our APIs, basically we support that the consumer can tell the API about its whole context if it knows it. And our web applications at the moment can do that. They give the whole context, they get one set of key values, and they use this cached more or less statically until they get an update. In other applications where you want to vary by user specifics, of course you have to do it differently. You have to analyze every single request. Here you see an example. Key is available for user. It has a data type boolean. All the things in our storage are then finally stored as strings, but in order to have some kind of verifications and validations on the back office, everything is typed. And you see then the values. So this is the default value. It's false. Simple Boolean value. You can vary it by brand, channel ID, culture, player category, and environment. And you then see different values depending on different contexts that you can specify. You can see multiple levels of overrides, for example. So the default value is false, but for Party Poker New Jersey, it's true. But if it's Party Poker New Jersey and the user is using English and not logged in, then it's false again. So different levels of overrides are necessary to achieve the flexibility that we wanted to have. Of course, the values you see here by sorted then by specificity. What's then also interesting was when we have implemented the first version and handed it to users. I mean, this was some kind of agile project, of course. We found out that the things that we want to vary by, like the culture, they might not be just flat lists. So for example, for the culture, we found we want to be able to vary by one culture explicitly, but also by the parent, like English here and English Jamaica. So you could vary by both if you want. The same for environments. Some people came and said, I have my project test environment QA23, and I want to vary values by that, but in general, it should take all the values from test. So we made QA20 whatever part of test, and then others came and said, actually FVT should also be linked in here, and then it was quickly quite complicated. But easy to use for the customers, because they can see these variation values that you can use in here. You have these nice tree views, and that's then good and self-explaining. What of course was necessary to do also is some kind of preview. People can hand in their context when they go to the back office. They can say, I want to see values for bwin, prod only, and they can basically then browse all the key values for a specific combination. Or they can see everything if they need to. Yeah, one thing that was also important for us is to handle shared components. As I said, we have a core team that delivers shared components, framework, different other libraries. And we thought about how can we best support our development teams getting the required config for this shared stuff. We are using NuGet as our repository where people can get the updates from. And actually, there is no push usually of updates to the development team. So when there are new shared components, it's more like they can take it when it's convenient if there's not a specific thing to fix and we have to rush it out. So we wanted to support this model. They should be able to update. When they update, they get a new config as required. This we have then implemented in our general configuration provider. This can look at the libraries, find out what version of config this library needs, and then is automatically fetching it in the background from the from the API. Another model we had in the beginning, but this didn't work so well because it was not so flexible. It would have required the development teams to go to the back office, say, I want this component in this version, and yeah, you can imagine how fun that would have been. And after discussing the use case for half an hour, we said, no way. The other difficulty we got with that was then that we wanted to see who are actually the customers and what are their combinations of libraries and so on. So we have to now find it out via other options, looking at analytics, but it's much more flexible for the teams. Secure handling was definitely important for us, so we wanted to have the possibility to have public and private containers, access control. We implemented a role-based access control model where people can have administrative development and editor rights. So the editor is basically the one that is allowed to change values. Whereas the admin and the developer are allowed to change also keys and the structure, because in our implementation we don't use key enumeration, which would mean we load keys and see what is there. We have an interface to the configuration, and we assume that the structure given by the containers and the keys is fixed. This is working very well because we have some other opportunity to work around that with complex objects. I will talk about this later. So editors can change the values, developers the structure, and depending on the criticality or other things, there might be then an approval workflow. We wanted to have a self-service administration system in place, so it is very important that there's no central team necessary to support this. People that create their containers can also manage their own permissions. All the changes are collected in change sets, so it's like a commit basically. You go to the system, you touch something, then this is already going into some shopping basket change set, and when you're happy with your changes, then you hand them in for publishing. Then it goes through a workflow, and depending on your permissions, it can go online or it has to be approved by some other party. All the changes, of course, are collected in audit logs, so you can see what was the state of this application in this time, what was the difference between all of these configs, and so on. So what is our current usage level? Who is using the system? What are our experiences with it? We have 900 machines loading the data from different environments. To move a bit here. 600 from production, 300 from different development test environments. You see we have quite some number of keys and features, containers. About 40 change sets get published per day on average. This change set is usually sized of 5 individual changes. 100 distinct users are publishing change sets per month. So the business analysts, testers, and so on that are working with the system. 20% of all the keys are JSON. In the beginning, I was not sure if we actually want to support that, but our old system had it in place. I saw it basically as a black hole, because in a JSON key you could have a complex object structure of whatever, but yeah, we had to support it. We tried to secure it. We support JSON schema on the key, so when you create the key and say it's JSON, you can have a schema validation based on all the values. We have fun features in where you can even merge the JSON through the levels of override, so you can have a default value that is then merged with the other layers coming from more specific values, and this is quite frequently used also by development teams when they see no other option. Yeah, so this is how we are using it. Now to what we found important to handle this in a reliable and stable way. So one thing that we did was we wanted to make sure that all the consuming applications don't really have a hard dependency to the provider API. So they should be basically isolated from it. They get the configuration when it's there. They have to live with it. If there's no update, it's good. They continue running. If the core config delivery system down, shouldn't matter. The client applications need to be able to continue running without the core system. Of course, when you have something like this in place, then you need to make sure applications can also randomly restart if necessary. So we had something like a last known good config. All the consumers that get a new version of the configuration and they find it useful, we have some checks on that, they can switch to it then, and they also store this version. So when there's a restart, they can work with it. Other systems implement some kind of fail fast pattern, but as we have a central monitoring based on it, already when the application is up and the health checks are running, it tells us something. We have health checks on all the relevant parts of the systems. What does that mean? All the applications, they are exposing endpoints that give meta information about the health of the system. Am I feeling well? Am I not feeling well? What is my problem? We have central monitoring based on that, and there's a first level support team that is looking at all these checks and alarms, and if there's anything wrong, then they can immediately trigger some action, either by resolving themselves or informing other teams. The consuming applications themselves can also check the configuration when there's a new version coming in. So they can have any kind of client or consumer check, basically. That would be too complex in a back office. So they could say these three keys, they somehow belong together, and if this key has this value, then there needs to be a certain combination with other things. We didn't want something like this in the back office. It would be too complex, but the client applications can check it. And if they feel that the configuration that they receive is not appropriate to their needs, they make this information available via the health check as well. No multi-level caching on the client side. This was for our developers a bit of a change because, as I mentioned in the beginning, on these web framework-based applications, the config was always immutable. You could cache it, put it in the IOC container. You could trust it's not updating. Now it's different. Don't cache it anywhere because otherwise the business analyst wants to change a value. There's a new update and some other layer is caching it and doesn't get the new version. So all layers of code need to get this from the single configuration provider that cares for the caching and all the things in the back. Yeah, you have to protect yourself from breaking changes to the configuration data. So we specifically mark production data as soon as it's going online. Actually, if it's not marked, it is not exposed for a production environment context. Why did we do that? Because we had a very important requirement in the beginning that this system is not allowed to make the work for the developers inflexible. So everything before prod, they should be able to handle, update, change. But as soon as it's on production, there's more checks assigned to it. So we had to have some border in it. We also make sure that users can try out changes in a safe way locally before publishing anything. We have different features in place. You can have a change set just for your own that you use on your machine or on a beta machine. We have local session overrides. You can go to the consuming application. There's a page where you can have all kinds of overrides just for your session. And then try out all the changes there. So we have not implemented that on production, but we could have a preview server that is running full production code, connecting to all backend services, and try out feature switches, for example, there. Yeah, and last but not least, implement a feedback channel, so you can have kind of automated handling on the core system side. How we are using that in the moment is we are trying to notify the editors and approvers of changes that are invalid. So when the application is finding out I get new config, but I don't like it, whatever, it's giving this information to the core system, and then the core system is notifying the ones that have created the mess. What you could also do as soon as you have this back channel, of course, you can have some kind of feedback already while the change set is developing or when it's handed in for approval. So you can have a change set waiting for approval and there needs to be some client checks already coming in before actually a human is saying it's fine. So we have not done that yet, but we think about it. So Now I'm already at the end of my talk. I want to bring your attention to tickets that we are giving away on the bwin booth. So if you are interested, feel free to come to our booth. It's right outside. And otherwise, thanks for your attention. If you have any questions, I'm happy to answer. If you want any more specifics or detail, I'm also available outside then for your needs.
All right, thank you. Thanks, first of all, for the speech. Yeah, thank you. And we have 2 questions here sent in from the app, and then we will pass the mic if necessary.
Okay.
How do your clients consume configuration changes without restarting? For instance, database connection strings. Does it require lots of code to the applications?
Well, database connection string is probably not the best example because usually it's not changing, but you can implement it in a way that you reinitiate the connection with a new connection string. But as I said, usually we are using it for less technical things. The reason why we also moved all technical configuration is for transparency, for documentation. If you want to see where the connections are going, want to change them on all kinds of consumers at once, you can do it there as well.
Thank you. And the next question is, do you have versioning? So what if an old app version requests the config and expects an old config scheme?
Yeah, sure, we have versioning. As I mentioned, so we have explicit versioning on the layer of the container and the feature, which means an application that is having a new artifact version, a new build version, might or might not need a new configuration version. And that's decoupled. So the application config version is different from the artifact version. So one artifact can address one config version. And of course, it's up to the maintainers of the tool to keep it there. So I've not heard of any issue where an admin of a container deleted version 1 and its application still wanted it. And of course, our health check would show it quickly.
All right, thank you. Do we have any more questions here inside? Any hand signs? No. Do you want to add something to your talk, or?
There is someone who looks like he has a question.
Ah, there. Big hands. Right. Nice. It's really hard to see.
Hello. I have one question. You said that you configure your configuration, you can combine it with change sets, and they go through an approval workflow. Is this an automated workflow? Is there user involvement included when the config gets approved? Or did you mean that this is based, for instance, like that only one session gets the configuration, this is the approval?
No, the approval that I meant is really a person having to look at it. So, for example, an editor is doing a change in a part that he is not having the permissions to put it online. Then a developer or if a tech lead, for example, needs to have a look at it. We have some keys that marked as specifically critical, and for these, depending on the level, a developer or an administrator needs to have an explicit look at it. And of course, there's then some screen where he can check what is in there, what are the differences, and he can even send it back and say this has to be fixed, and the other guy can do that, hand it back again, and that's then the way it's going online finally.
Thank you.
Anyone else? I see a hand. There is a hand. Nice. Next turn. Ah, you again.
Hi. What is the round trip time for your configuration things, and how does this impact performance for requests which have to be updated? The configuration have to be updated on a user basis.
You mean with round trip, how fast it is getting from the click of publish that is then finally approved to getting used?
From the server, if you need a configuration on a user basis, or whether it's in German or in English user, and how long does the server take till it gets the information what's the appropriate configuration for that user?
So the client-side resolution is, I think, a non-issue. This is not even milliseconds. The time that it takes you click on the publish button and it reaches the server is a bit different, because we want to make sure that all the servers get the information at the same time. So in this poll concept, we have now it's 2 o'clock. The config is valid from 2 o'clock and 30 seconds. Then all the consumers are polling 2 or 3 times. They get the config and they prepare it in the background. They can even prepare, if you click several times publish or several people are doing it, then you can have several upcoming change sets. And even they are checked in all the applications and health checks report on them. And when the time, and until this is valid, the late old config is used. When the time is then there, new one is switched in and immediately used.
Nice. So thank you, Peter. I guess if any one of you has any more questions, you will be at the bwin booth
yes.
At some point. And yes, thank you for your talk.
Thanks a lot.